Hello everyone, my name is Lakshay. I welcome you all to the discussion of AIATS plus mock test 7. So in this paper or in this slot we will be discussing with the organic section of class 12th, and the chapters are alcohol, phenols, ethers, aldehyde ketones and carboxylic acid as well as amines. A very good morning to you all. So let us start from the very first question here. Okay, we have question number 55. So in this question you will be having an alkyne and you are doing the hydration of it. Okay, so in this part you are doing the hydration, but in the presence of catalyst, or we can say that the catalyst here is mercuric sulfate here. In this part the mercuric sulfate is used as an catalyst over here. So let us try to discuss the mechanism first, so that you can solve that question very easily. So let us start from the mechanical approach. Okay, let us say you are having a substrate called pH C triple bond CH. Okay, and now you are hydrolyzing in the presence of Hg positive. Okay, so what will it cause? It's simply the very first case is it simply bind it. Okay, when it simply bind it, you will be getting a mercurious salt. Then you are hydrolyzing it. You will be simply getting, first of all, you will be having pH C double bond CH as well as OH. Always remember, in hydration you will be getting this kind of product, which it is called as enol. And on tautomerization, we can say that on tautomerization you will be having pH C double bond O CH, or we can say that it's H over here again, CH3. This is the final product of the question. Is it clear? Is it clear, you guys? Okay, let us check which question correlated. The product of this question is pH C double bond O CH3. This is the final product of the reaction. So from our opinion, option 2 must be the correct answer. I hope this is clear to you all. Okay, let us move to the very next question. You will be having question number 63. Just a second. Okay, let us start from the question number 63. You will be having an alkyl bromide. So in this part, we can simply take the two kind of alkyl groups. Let us say you can take an aliphatic alkyl halide, or we can say that you are taking RBR. R can be alkyl halide, or we can say that aliphatic or aromatic. And now in this part, in this very first part, you should consider that aromatic bromide cannot be the case. And why is it so? Because you are reacting with NaCN, and NaCN will not gonna attack to RBR. And why is it so? Let us check. You are taking RBR like this, but NaCN will not be able to replace that bromine. And why is it so? Because of having the lone pairs on the bromine, there will be the partial double bond character in the carbon halogen bond. So aromatic aryl, or we can say that aryl halide can't be the case. So we have to consider the aliphatic alkyl halide by continuing the reaction. So let us say you are having RBR and we are reacting with NaCN. Let us try to write the nucleophile over here. Let us say the Cn negative. What will it can show? The Cn negative will act as a nucleophile and it have an anti-bonding orbital. So the nucleophile will attack in the empty antibonding orbital and will show an SN2 reaction. Can show SN2 and you are getting RCN. This is the A part. Okay, and next, this is, we can say that this is X. On moving to the next reaction, you are reacting the X with DIBAL-H in the presence of water. So let us try to move it. See, you are getting RCN, or we can say that you are reacting with DIBAL-H. In the previous session, we have undergone a lot of variety of questions regarding the DIBAL-H. Let us try to remind some of you so that you can use the DIBAL-H concept here as well. Let us try. So what is the definition of DIBAL-H? This is, we can say that the full form of DIBAL-H is diisobutyl aluminium hydride. And the structure of DIBAL-H is very much common over here. It's Al, H, and isobutyl groups are there. This is the formula of DIBAL-H. And in the very last session, we have been gone through that the DIBAL-H is a contractor of aldehyde. This is the contractor of aldehyde. So what it can show? This DIBAL-H on reaction with first RCN will convert to RC double bond OH. And let us say, and another example, if you are taking an ester group over, so RC double bond O, OR, on reacting with DIBAL-H, you will be getting again an aldehyde. Always remember, you are reacting the DIBAL-H at a very low temperature. And if you are reacting this whole DIBAL-H into a reactant at high temperature, the alcohol can be the case. Okay. If it is clear, let us back to the question again. If you are reacting with DIBAL-H, you will be getting RC double bond OH. This is very much clear that DIBAL-H is written, it means you are reacting at the low temperature. We can see that the low temperature is around minus 78 degrees centigrade. Okay, it's that much too low. So your final product could be aldehyde. Okay, so let us check which option must be the correct. So this can't be the case, this can't, this is the case. But if you are reacting the DIBAL-H at a very high temperature, then this could be the product as well. Okay. Is it clear? Okay, let's move to the next question. We are having question number 64. As per this question, you are reacting, or we can say that ethanol in presence of sulfuric acid at 413 Kelvin mainly gives. This is very important concept. And in this reaction, ethanol on reaction with sulfuric acid is simply a temperature dependent reaction. We can try to go into the as depth as possible so that you guys must be aware that which product will be formed at which temperature and the reason behind it. Okay, let's start from the very basic. You will be having, let us take, you will be having an ethanol, CH3, CH2OH. Simply, you are reacting with it and concentrated H2SO4. Let us try to make an H positive. Okay, so what will be the case? The first case is that OH, the lone pair of OH, will attack to this electrophile or proton to get CH3, CH2OH2 positive. This will be the very first case. Okay, and now you are having the two possibilities for this reaction. Now what are they? At the very first insect, you can know that there is a presence of HSO4 negative over here, and there is a possibility that the ethanol is present in the excess amount, or we can say that the left ethanol will try to attack at this position. And how is it? Let us try to understand. Let us check in first case. In the very first case, let us check, you will be having left an ethanol. And the electrophilic center is this. You are reacting with CH3, CH2, OH2 positive. So what will be the case? Now, the lone pairs of OH will act as a nucleophilic center, and now this is an electrophilic center over here. So the lone pairs of this will attack and removal of water will take place, and you will be having C2H5O, C2H5. Let us say this is the product A. And you guys are so much aware that why we not convert this into CH3, CH2 positive. And why? Because this can't be the case. And why will it not be formed? Because you can clearly say that the positive charge of the carbocation is not that much stabilized over here. Why is it so? Because of the presence of CH3 group, or we can say that there is only 3 alpha hydrogens over here, which makes it extremely difficult to produce it. Okay, so this can't be the case, or we can say that this can't be generated. So we are only the two cases. First is that we can attack the OH of ethanol to this, and you will be getting an ether. We can say that this is diethyl ether. Or in the next case, let us say it's case number 2. In this part, the left position, or we can say that CH3, CH2, OH2 positive. And there is a presence of HSO4 negative. The HSO4 negative can undergo an elimination reaction. Or we can say that if we write this in the form CH2H, this HSO4 negative will abstract that proton, and this bond will move over here, and removal of water takes place. And what will you get? You will be getting CH2 double bond CH2. We can say that this is ethene. These are the two possibilities. So let us say this is product B. Now you must be gone with a confusion that which product is to be major and which is minor at which temperature. So let us try to go into the depth of the portion. Let us say you are reacting this with H positive or concentrated H2SO4. Okay, so what will be the case? The positive charge will not be formed. Now, if you are reacting at the very low temperature, we can say that 413 Kelvin. If the temperature is 413 Kelvin, now the ether will be the major case, because the elimination reactions are thermodynamically controlled reaction, and to carry out that reactions you will be having a very high temperatures. Okay, so in order to carry out these reactions, we can say that case 2 reactions you will be having higher temperature, or we can say this will occur at 443 Kelvin. So at high temperature ethene will be the case, or at low temperature diethyl ether will be the product of this reaction. I hope this is clear to you all. Is it clear? Okay, let's back to the question, and what does the question suggest? Okay, now in ethanol, in the presence of sulfuric acid at 413 Kelvin mainly gives, this is 413 Kelvin, it means the product is diethyl ether. Is it clear? We can simply make a chart over here. Let us say C2H5OH, you are reacting with conc H2SO4. Now the temperature is varied. If you are performing the reaction at 413 Kelvin, the diethyl ether C2H5O, C2H5, this will be the major product, or we can see that this is major. And if you are reacting with 443 Kelvin or higher temperature you are been taken, you will be getting CH2 double bond CH2. This is a final, we can say that, flow chart of this kind of reactions. Is it clear? Absolutely correct. You can make a box so that you guys can be easily understood by this. So option 2 must be the correct answer. Is it clear? Okay, let us try to make one more question regarding the same concept and try to get into the depth. Okay, let us say you have taken this and you are reacting with conc H2SO4. The temperature you can take whatever do you. Okay? In this part, if you are making this, the H positive will be taken by lone pairs of oxygen. So that very first step, you will be getting OH2 positive. Now, if you guys were thinking that the lone pairs of oxygen will attack to this and removal of this will take place, this can't be the case over here. And why is it so? Because the carbocation after the removal of this is already very much stable. So because this will not be happen at the very first insect, at the very first step, you will be having a carbocation. If the carbocation is formed, you will be having a dehydration. We can say that directly HSO4 negative will attack and you will be getting and this product. Here the carbocation can be easily been prepared, okay? So here no SN2 reaction, no formation of ether. Or we can say that in secondary or tertiary alcohols, no ethers will be formed via using these kind of reactions. I hope this is clear to you all. Only if you are taking the primary alcohols, then the ether can be prepared. Absolutely correct. Hydration will occur perfectly. I hope this concept is clear to you all. Yes. Shall we move to the next concept? Okay. Okay. Now we have question number 65. Which of the following is most basic in nature? In the previous sessions, we have been understood about the basicity, or we can say that basic character, we can say that basic strength of amines. And in that portion, we have already covered there are lone pairs, and we have already classified the lone pairs in the two parts. What are they? The first one is localized and other is delocalized. And in delocalized, there we will also been further classify that delocalized are of two types. The one, in the very first case, the lone pairs are involved in the maintaining the aromaticity of the compound, or we can say that making the aromatic compound. And in the second part, there will be only delocalization, do not maintain. Aromaticity. So we have already gone through the point that localized lone pairs are more basic in nature because they are already available at that point. So localized lone pairs are more basic than the delocalized one, which is not maintaining the aromaticity of compound. And the very last basic is the aromatic lone pairs, because the lone pairs present in the aromatic system will never be used to abstract a proton. If the proton is given to it, it will never take it. So because this will not be and at all basic. Okay, let us try to move into the depth. In the very first part, we can say that the lone pairs of nitrogen is involved in aromaticity. We can say that this is primary aromatic amine. If we classify, this is simply an aniline. Okay, in the very second part, this is also the lone pairs is localized in that portion. This is also same. moving to the next part, in this, the lone pairs is also involved in this. But at the fourth step, you have clearly been observed that this is benzylamine. In this, the lone pairs of nitrogen is not involved in any kind of resonance, so we can say that it is not been delocalized. We can say the lone pairs of this NH2 is localized. If the lone pairs are localized, it means they are more prone to attack to the H positive, or we can say that this is more basic in nature. So we can clearly say that option 4 must be the correct answer. Absolutely correct, Hilal Sophie, that benzylamine has a localized lone pair, so it will be more basic. Absolutely correct. Option 4 is the correct answer. Absolutely correct. Or we can say that this is primary aliphatic amine. Absolutely correct. Shall we move to the next part? Okay, that's very impressive. Now we'll be having question number 67. Which of the following will not give positive test with CHCl3KOH? This is also kind of repetitive question because that question is very much important as per the NEET demands. This is simply a carbylamine reaction because you have been given the aniline, or we can say that the NH2. In the previous sessions we have already gone through the point and the whole mechanism regarding the carbylamine. Just we will give you just kind of glimpse over here. So let us try to make a chloroform reaction. We have been gone through about carbylamine reactions. So in carbylamine reaction, this is very much clear that, absolutely correct, primary alkyl aromatic amines. Okay. So in carbylamine, we can also say that this is isocyanide test. And why is it we call it, you will get to know in the later part of this question. So in carbylamine reaction, the very first and foremost thing that this will be given by only primary amines. No secondary, no tertiary will give that kind of reaction. Only primary amines will give it. Absolutely correct. So in this part, you will be having, let us take an example, you will be having aniline. Let us try to make an aromatic primary amine. And you are reacting with CHCl3 in the presence of KOH. So the very first and foremost step, we can say that, we can go with the stepwise manner. Step 1. So these are the reagents they will react with very first instant, and now you will be having CHCl3 plus OH negative, and if you write it H in the form the OH negative will abstract it, and we can say that you will be having CCl3 negative, and after CCl3 been formed, it will be very much stabilized, but you can show that this will undergo an alpha elimination, yielding CCl2 lone pairs. We can say that this is, always remember, these are not the lone pairs on the species. This is electron deficient, and this is carbene. And very specifically, you can say that CCl2 is which kind of carbene? Is it a singlet or triplet? Write down in the comment section, please. The carbene formed, that the CCl2, is it a singlet or triplet carbene? We will try to get into the next. So the carbon formed, we can say that CCl2. Now this is an electrophilic center and you will be having aniline. So on reaction with aniline with CCl2, this is an electrophilic center, this is nucleophilic center. Now the lone pairs of this will attack to this position. You will be having N H2 CCl2 negative and positive charge will be there. Now the intramolecular hydrogen transfer will be occurs. The negative charge will take the proton and the charges will neutralize, and you will be getting NHCHCl2. Now they will be having the lone pairs of nitrogen, so it can show the lone pairs will go at this bond and removal of Cl negative will occurs. Now the Cl negative will occurs, you will be having NHCClH and double bond is there. Now again the Cl negative, the released Cl negative will take this hydrogen, or we can say that the positive charge is here. So for the removal of that hydrogen, the Cl negative will bond with it. So you will be having a simply minus HCl, you will be having N double bond C, Cl, H, this could be the case. And in the very next step, the lone pairs are still present on the nitrogen. The lone pairs will again move to this, removal of Cl will occur. You will be having N triple bond C, H, it's positive and Cl negative will take it, and you will be having N triple bond C, or we can say that this could be the case. The isocyanide is formed. Absolutely correct, Hilal Sophie, the singlet carbene is formed. And why not triplet? Because the Cl negative, we can say that this lone pairs of Cl will be available to donate in the vacant orbital of carbon and making the singlet carbene the most stable carbene as compared to the triplet carbene. Very good, Hilal Sophie. So you will be getting isocyanide here. You can clearly identify the isocyanide because it is having a very foul smell. This is foul smell. So from this kind of explanation, you will be having to know that the only primary amines will give the carbylamine test. Is it clear? Moving back to the question part, you will be having this is primary amine, this can give, and you have to identify which will not give the positive. So this will give, this will also give, this is also primary, it can also give. This is 3-degree amine, so it will not give an carbylamine reaction. So this is the correct answer to this question. Dharani from class 11th or fully combined. This session is purely been based on your NEET examination, so it is fully combined. It's from both 11th and 12th, but the chapters were being distributed in the different slots, so move accordingly. So this is the answer to this particular question. Shall we move to the next part? Okay, moving to the next part. You will be having question number 73. In this particular question, you have to identify X in the following reaction, and the given reaction is this. This reaction is very much common to you all guys. Can anyone give me the correct answer to this? Or shall we proceed with an explanation? absolutely the benzaldehyde will be formed. The name of this reaction is absolutely. Hema Malini, the electricity, has given the absolutely correct answer. Okay, let us try to go into the depth of the question so that you guys must be aware about the name of this. Okay, so then you will be having this benzene reacting with carbonyl in the presence of HCl, and you will be having anhydrous AlCl3, any kind of Lewis acid you can take over here. Okay, so the name of this reaction, this particular reaction is, this is Gattermann-Koch. This is Gattermann-Koch reaction. Remember? Yes. So Kanya has given the perfectly correct answer that this reaction is Gattermann-Koch. So in moving this question, you will be reacting the benzene with carbon, or we can say that CO, carbon monoxide, in the presence of base. You will be getting a product called benzaldehyde. The name of the reaction is very much important. The NEET will directly ask, the NEET will directly give you this reaction and will ask about the name of this reaction. So it must be very much clear that this reaction is Gattermann-Koch reaction. If the name arises the Gattermann, so shall we go the other reactions which been given by the Gattermann? Very good. So let us say there were mostly the three reactions we will understand. What are they? The first one is Gattermann-Koch. And in the haloalkanes or we can say that in amines, you've been discussed about Gattermann reactions. So there is a difference in between the two reactions. Always remember, if the word Koch is mentioned, you will prepare the benzaldehyde using benzene in the presence of CO and HCl. That we have already done. And if you will be given only the Gattermann reaction, you have to go into the diazonium salts. So we can say that diazonium chloride will be the reagent while using, or we can say that diazonium chloride is a substrate to that reaction. So in this part, in Gattermann reaction, there is a diazonium chloride. Let us say N triple bond N positive and Cn negative. This will be the substrate of this reaction. And you are reacting with copper in HCl. Always remember, you will be taken and copper directly in the presence of HCl. You will be getting chlorobenzene over here. And if you change the HCl with HBr, you will be getting the bromobenzene. So this is Gattermann reaction. The only difference, absolutely correct, the diazonium chloride we have taken. But if we have changed the reagent and you will convert into the Cu2Cl2 in the presence of HCl, the product is more or less same. You will be getting the chlorobenzene, but the name of the reaction changes. What will be the name of this reaction? Now, this reaction, N triple bond N positive, Cl negative. Now, this reaction will be known as Sandmeier's reaction. This will be known as Sandmeier's reaction, and this is Gattermann reaction. Very good. I hope this concept is clear to you all. Shall we make a flow chart so that you can easily remember it? Let us try to make it. Let us say you will be having two kinds of reaction. The first one is Gattermann. The other one is Sandmeier's. the only difference you are reacting with, you have been reacting with diazonium chloride. And here the reagent is Cu HCl. Here the reagent is Cu2 Cl2 in the presence of HCl. The product formed is chlorobenzene. Is it clear? I hope this concept is clear to you all. Shall we move to the next portion? And if Gattermann reaction, Gattermann-Koch reaction is been asked, you will be converting the benzene plus CO plus HCl in the presence of anhydrous AlCl3, you will be having benzaldehyde. The all is being written in that portion. Gattermann-Koch. Shall we move to the next question, please? Is it clear? If you guys have any kind of doubts, you can clearly ask me. So moving to the next part, we have question number 74. Okay, that is very interesting question. You will be having a tertiary butoxide, sodium tertiary butoxide, and you are reacting with haloalkene. This is very important reaction, and what will be the case when the reagents, when the substrates were being changed? We will try to get into the as depth as possible so that your question must be clear. Okay. So, taking this question, let us try to make the concept. You must be aware about the term Williamson synthesis, and this question is regarding the same. Okay, electricity, we will definitely clear your confusion regarding it, but before it you can go with it. Absolutely, Williamson synthesis. So in Williamson synthesis, you've been given an alkoxide ion. We can say that RO minus Na plus. You are reacting the alkoxide ion to alkyl halide in the presence of dry ether. So what will be the case? Now, always remember, the O negative will attack in the antibonding orbital of carbon and halogen. So what will you get? You will react in it here, the X will remove, and the product is ROR dash. We can say that this reaction is SN2. Or I can say that the reaction follow SN2 mechanism. So what will be the case? If you are reacting, let us take an example. You are taking CH3O minus Na plus, and you are reacting with CH3Cl. Let us take an example. And you are reacting in the dry ether, and the product is the O negative will attack over here, the Cl negative will remove, and the product is CH3O and A. Is it clear? This is very much simple over here. Let us try to take another example. Let us try. If you are taking a bulky base, or we can say that bulky alkoxide, let us take, you have taken O minus Na plus CH3 CH3, CH3. Tertiary butoxide ion we have been taken. You are reacting with again CH3, Cl. Now what will be the case? The O negative will attack with the antibonding orbital. You will be getting OCH3. This is the final product being formed. So what will be the case when you have been taken CH3O minus Na plus, you are reacting with Cl in the presence of dry ether. So what will be the case over here? So if this will attack over here, the most simplest approach you can go, you will form the product called CH3O. This will be formed, है ना? Is it clear? But this will never be formed. This will never be formed. Why is it so? Because the nucleophile is non-hindered. That not been the case. But if it is reacting in the antibonding orbital, the antibonding orbital of carbon and halogen bond is very much sterically hindered. We can say that no SN2 reaction possible. If there will be no SN2 reaction, so this will not attack to this hindered haloalkane. So this can't be the case. Is it clear? So what will be the case? You will be directly getting an alkene, or we can say that elimination product must be favored in that kind of reactions. Is it clear? So moving to the question part, okay, we can clearly see that the haloalkane part is non-hindered. If this is not hindered, then the O negative will directly attack to this position, or we can say that antibonding orbital of carbon and halogen bond, and will remove the halogen from it, and you will get a product formed. What will be the product? CH3, CH3, CH3O from that portion, and the CH2, CH3 from that. This is the final major product. Okay, so it is clearly been observed that option 3 must be the correct answer. Is it clear? So option 3 must be the correct answer to this particular kind of question. Shall we move to the next portion or next concept? Okay. Now you will be having question number 76. In the previous question, you've been asked to prepare an ether. Now, in this portion, you have to cleave ether. This is very much important cases. And this is the beauty of these questions. At first, we've been asked to prepare an ether. In the very next portion, you've been asked to cleave it. Absolutely. Let us try to check whether option 3 is correct or not. Trying to do in this question, you will be having this ether. This is O and this is CH3. If I'm not wrong, this is the same substrate. Yes, absolutely correct. And you are reacting with HI, and one equivalent is mentioned. One equivalent is mentioned. So let us try to move it. you will be having the lone pair present on this oxygen atom. And the oxygen atom will try to obstruct a proton from it, and you will be having CH3, 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 O, CH3, and H is already, this is the positive charge formed over here. Is it clear? We can not be formed, it's only positive. Now, there will be the two cases. Either this will cleave or directly the SN2 reaction will occur. But we all have been aware about the fact that the carbocation after the removal of A or B, there are two possible cases from which the ether been cleaved. Okay. Now try to understand which bond is cleaved and which is not. In the very first case, if you have been taken from, if you are cleaving from A, you will be getting a very much stable carbocation form. Which is it? CH3, CH3, CH3 positive. This is the carbocation form, and that carbocation is very much stable over here. And if you've been cleaved from B position, you will be getting only methyl carbocation. That is extremely, extremely unstable, because it is not being stabilized by any kind of other factors. They will be not having hyperconjugation, no inductive effect, no stabilization. So this has been stabilized by both inductive effect as well as major factor is hyperconjugation. And there are, we can clearly say that there is a presence of 9 alpha hydrogen in that case. So the cleaving is, the cleavage of this ether bond will be occur from A position. That much is very much clear. And the 3rd degree carbocation has been formed over here. And the other product being formed is methanol. You can say that CH3OH. This is the other product form. You are reacting with HI. So what will be the case? And if you are reacting with HI, the H positive is earlier been utilized by a lone pair of oxygen. Now you will be having only I negative. The I negative will attack to this, and you will be getting CH3, 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 I. This is the final products which were being formed. I hope this is clear to you all. You've been given only one equivalent of HI. And that's not been the case, because if you've been taken the excess bit, the OH will not and taken, it can further be nucleophile, it will attack, the I negative will attack to this, and we can form the iodo, or we can say that methyl iodide, but it will be in the very less amount. And you've been clearly mentioned that you've been taken only 1 degree, or we can say that 1 equivalent of HI. I hope this is clear to you all. Okay, let us try to check the options. The product formed is CH3, 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 and I is there, plus CH3. Let us check which option is correct. There is ethanol as well as this. So option 3 must be the correct answer to this question. So the electricity and Lakshman Patil has given the absolutely correct answer. The option 3 is correct. Shall we move to the next part, or next conceptual question? Okay. You've been given by question number 79. This is very kind of easiest question in that paper. Which of the following is a secondary amine? Can anyone give me the answer to this question? This is one of the most simplest question. This been earlier been discussed at the GOC portion. J is given the perfectly correct answer. J. Option 2, okay. Okay. Everyone is that much observant that they've been given the perfectly correct answer. Okay, option 2, that's quite impressive. So let us try to get into the depth. Okay. In the very first part, we can clearly say that if you are having the amines, these are of kind of, we can classify into the 4, it can be 1 degree, 2 degree, 3 degree or 4th quaternary. This is very much simple that in that portion only, those amines with the nitrogen which been attached to only one carbon center, or it is that that amine is known as 1 degree amine. So simply, in this very first part, this nitrogen is clearly been attached to only one carbon center. So this is primary amine. Secondary amine means the nitrogen center is attached to 2 carbon centers. So in this portion, this nitrogen is been attached to 2 carbon centers. So this is hydrogen is there. So this is 2 degree amine. In the very third session, in the third part, this is the nitrogen is being attached to 3 part. Okay, 3 carbons. So this is 3 degree amine. And in the very fourth part, this nitrogen is being attached to only 1 carbon. So this is primary aliphatic or primary aromatic amines. So which one is second? The secondary amine is part number 2. Absolutely correct. Is it clear? I hope this session will help you in getting your doubts been cleared, or the many different concepts which are being very important to you all guys were being cleared in that kind of session. Absolutely correct. I'm just giving you one question for you all guys. You've been try to attempt at home and write down the correct structure, or we can say that the correct IUPAC name of the compound or major product. Okay, let us write down a reaction. If you are reacting this, let us CH3 NO2, or simply take OH CH3, and you are reacting with, remove this as well. Let us try to take it very simple. What is the major product formed, and what is the IUPAC name of this? Do solve it, and what is the, this is question number 1, question number 2, and question number 3 is name of this particular reaction. I hope this is clear to you all. Yes. So please attempt it and write in the comment section, so that I've been very much been aware that you guys been aware about it. So thank you everyone. We will meet you in the next class.